Here's another podcast on solving quadratic equations, this time using something called the square root property. I've written the square root property up at the top here, but it came out kind of small, so I wrote it again over here on the side. The square root property says if you have some number, it may be a simple number or it may be some big mess like 5x squared minus 11. If you have some number squared equal to another number, and I call it here M for mess because it could be messy. So if you have some mess squared equal to a number, then the mess is plus or minus the square root of number. Again, I wrote it over here on the side. Let's see how we'd use it to solve a problem. In example 1, my mess is the 3x minus 5, and it is squared. We call that a perfect square when you square a number. And the 3x minus 5 squared is equal to the number 6, so that's just like in our square root property, mess squared equals k, mess squared equals k. And the square root property says then the mess is equal to positive or negative the square root of k. So I write the 3x minus 5 is positive or negative the square root of 6. Now, I'm trying to solve this for x, so I move the 5 to the other side. Now I have 3x is equal to 5 plus or minus the square root of 6, and to finish solving for x, I divide both sides by 3. And that is an acceptable form of your answer. If the square root of 6 could be simplified, I'd simplify the square root of 6, and maybe through some later manipulation I would get to cancel out the 3, but that's an okay form of the answer. This is what that means. It means you get one answer, 5 plus the square root of 6 over 3, and the other answer, 5 minus the square root of 6 over 3. So that would be the best way to show your answer. Now in the second one I again have a mess squared, but I don't just have a mess squared is equal to k. I have a mess squared plus a number equals k, and that's not the way the formula goes. There isn't any plus a number here. It's just the mess squared is equal to k. So I've got to get rid of that number, so I subtract 7 on both sides. And now I have my mess. My mess is 5 minus 2x. My mess squared is equal to my k. My k is negative 3. So the square root property says the mess, 5 minus 2x, is positive or negative the square root of negative 3. Well, we know that we don't leave anything in that form when we're dealing with complex numbers. We always put them in the I form. So we'd say positive or negative I square root of 3. Well, I need to keep solving here until I find x. Right now x is not by itself. It's there with the 2 and the 5. The first thing I'm going to do is get rid of that 5. So I subtract that from both sides and I get negative 2x is equal to negative 5 plus or minus I square root of 3. I divide both sides by negative 2. On the left, the negative 2 cancels. I now have x. Again, I can't really simplify the right. I can break it, however, into two different solutions. I could call it negative 5 plus I square root of 3 over negative 2. Or I could call it negative 5 minus I square root of 3 over negative 2. And I could factor negatives out of the top on that second one, especially since I've got all three negatives. If I multiply top and bottom by negative 1, I could call that second answer, this was supposed to be a comma, I could call that second answer 5 plus I square root of 3 over 2. First answer I can't really simplify too much, so those are my two answers. The third one is a little bit more simple. When you look at it, it doesn't look like something squared. It looks like something to the 2/3 power. But remember, you have a rule for square roots that says x to the a to the b is x to the ab. So what I could do, if I wanted to turn this into a mess squared is equal to 4, I could say x to the 1/3 squared is equal to 4. And then I'd have the mess would be x to the 1/3. And so I'd have the mess squared equals k. So the mess, x to the 1/3, is positive or negative the square root of k. Well, the square root of 4 is just 2, so that's positive or negative 2. Well, that tells me that x to the 1/3 equals 2, or x to the 1/3 equals negative 2. But how do I find x? Well, I could cube both sides. Then I'd have x to the negative 1/3 to the 3 equals 2 to the 3, or x to the 1/3 to the 3 is equal to negative 2 to the 3. Well, x to the 1/3 to the 3 is just x, because 3 times a third is 1, and x to the 1 is x. And 2 to the 3rd is 8, so I get one answer x equals 8, the other answer x equals negative 8. And that completes the podcast on the square root property.